Hi viewers, thank you for watching our channel. Today's topic, we're dealing with completing the square. What we have on our chalkboard, we said the quality to be added is the square of the half of the coefficient of x or any letter given. For instance, added a term to n raised to power 2 plus 1 whole number 1 over 2n to make the expression a perfect square. So when we're talking of completing the square, we say complete. That means we want the expression to be in perfect square, completely perfect square. So express the result as a square of a bracketed expression. Therefore, the coefficient of n is plus 1 whole number 1 over 2. That means half of plus 1 over 2 equals, the workings out, how we get that one, the half of this, it should be equals 1 whole number, that means half times 3 whole number 3 over 2. How did we arrive to this 3 over 2? That means we multiply 2 times 1, 2, plus 1, 3 all over 2. That's why we arrive here. So the half of this half, by going through this process and method, gives us 3 over 4. Then this 3 over 4, we need to look for the root of it. So from checking the root of this one is what we have here. That means it gives us, open bracket, 3 over 4, close bracket, raised to power 2 equals, the root of this is going to give us, now that means raised to power 2, 3 raised to power 2 equals 9. Then 4 raised to power 2 equals 16. Must be added to our first value here. This particular 9 over 16 must be added to this equation to make it what? Perfect square. So from here now we said n squared plus 1 whole number 1 over 2 plus what we get here. We got here the first time 9 number 9 over 16 equals, open bracket, n plus the half of the coefficient bracket raised to power 2. We have some examples, but once we can get this way of bringing out this expression, it will be easier for us to solve some of our examples. Let's see what we have here. Add the terms that make a given expression into a perfect square. We're trying to make each and every one of this equation to be in a perfect square. So let's start from the first equation. First equation here is a squared plus 8a. Like we said here, we will look for the half of the coefficient because the coefficient of a here is plus 8a. So we are looking for the half of this one. So therefore, it will now be half times 8 over 1. So meaning equals 8 all over 2. 2 here 1, 2 here 4. So the half that we have here equals a plus 8a equals 4 here. So as we got in 4 here, we need to look for the square root of it. So we must raise it in the power 2. So that means the coefficient that we're looking for, 4 raised to power 2, is going to give us 16. So from now, our equation will now be a plus 8a plus 16 equals, open bracket, a plus this very particular half here, half of the coefficient 4 bracket 2. So by this equation is already given on a perfect square. Perfect square, because when you multiply this one together, we're still going to come back to this. 16 with the square and with the 8 is going to give us. So we won't go further. This is how they want us to make the expression to be perfect square. Let's check the second equation too. Second equation, we have question 2, b squared plus 10b. Like we said in our first example, we will look for the half of this coefficient. So this one will now give us 1 over 2 times 10 over 1. So equals, this is 10 over 2. When you now divide 2 here 1, 2 here 5. So what we have here is b squared plus 10b plus equals 5. Then we look for in raised to power. So that means 5 times 5 is going to give us 25. Right? Then from here now, we now want to make it in an expression, to make it perfect expression. We want to express it. So it will now become b squared plus 10b plus 25 equals b plus they have here 5 raised to power 2. So as we said at the time, to make the given expression into perfect square, this is the perfect square that the given expression is we were asked to put. Let's work the third question too. The third one says 3c squared minus 4c. With this one too, we will follow the same procedure, making equals half times 4 all over 1. This one will now give us 4 over 2. 2 here 1, 2 here 2. So from our next expression, we will now put c2 plus minus 4c plus 2 yeah, okay. From here now, before we put that plus 2, we will get the raised to power of this one. So it will now be equals 2 raised to power 2. That will now, it will give us 4. That's 2 times 2, 4. So our equation will now be x2 plus 4c minus 4c plus 4 equals bracket c minus 2 raised to power 2. That's the perfect square we were asked to bring the equation to. Then let's look at the last one. M squared plus 2m. With this one too, we look for the half of the coefficient. So equals 1 all over 2 times 2 raised to power 1. So 2 times 2 times 1, 2 times 1, 2. Here we have 1. So here now, m squared plus 2m equals 1 bracket 2. So 1 times 1 is still going to give us 1. So we now bring the m squared plus 2m plus 1 equals open bracket m plus 1 raised to power 2. So this is the perfect square the equation is asking us to change the expression to. I hope this channel added value to you. Till we'll see you in our next video. I'm yours because he cares. Thank you.